Let's work together on solving a couple of equilibrium problems using the systematic method. So this is sample problem 2.2. The equilibrium we'll be using is AB2 in equilibrium with its ions A2 plus 2B minus. Problem tells us a couple of things. It tells us that we have a 1.0 molar solution of AB2. And it also tells us a value for K. So it says that K is equal to 1.0 times 10 to the minus 4. Notice again, this is big K and it has no units. So let's define our inputs, or what we know. Then we'll work on the equations that we know and determine what we need to solve for in Mathematica, or our outputs. Let's assign our variables. We'll call AB2 x, A2 plus can be y, B minus can be z. We are told that xi is equal to 1.0. Since this is at the initial conditions, A2 plus and B minus will actually be 0. So we can say that yi equals 0 and zi equals 0. And we also know that k is equal to 1.0 times 10 to the minus 4. To determine what our outputs are, look at what the question's asking for. It's asking for the concentration of A2 plus at equilibrium. So we could work in the concentrations of the other two as a factor of that. So what we want to solve for are concentration AB2 at equilibrium, which we'll call X. We want to solve for the concentration of A2 plus at equilibrium, which we will call Y. And we want to solve for the concentration of B minus at equilibrium, which we will call Z. Notice that we have 3 unknowns, and that means that we have to have 3 equations to solve for them. Your first equation is always going to be an equation for K. So remember, K is equal to concentration of products over reactants. So equation 1 is equal to K. I'm going to put 2 equal signs since that's how you have to do it when you're in Mathematica. Equals Y times Z squared all over X. Equation 2 can be your charge balance equation, which we'll signify by writing plus minus in parentheses. And that is going to equal 2y double equal signs z. And remember, to get that, you look at the charge on that first ion. Equation 3 is going to be a mole balance with respect to A, and that will look like yi plus xi is equal to y plus x. Since it was with respect to A, you're looking at these 2 species. We don't have to do a mole balance for B since we have the 3 equations that we need now to solve. At this point, you plug in all of your variables and equations into Mathematica. You will always get several solutions out of Mathematica. Make make sure to choose the ones that actually make physical sense. So you shouldn't ever get any negative values or irrational values, which have the little I next to them. So once you've plugged into Mathematica, get your answers out and make sure that you answer the problem based on what it's actually asking for. So make sure to give your answer in terms of concentration of A plus 2. Use the correct number of sig figs and units here.